Yes, so today we'll just discuss on digit extraction. This already I have discussed with you all, digit extraction. This means something like where we have a number, like for example I say int n is equal to, suppose say, um, 345. Now this is a number which I'm assigning it to n. Now this number which is assigned in n, there are some digits. If I want this digits to be extracted, I'm not saying removing, I'm using the word extraction. Extraction means just removing a copy out. So that I can do it by writing in this way, n modulus 10. When I divide any number by 10, say for example this 345, 10 is over here, 10 threes are, so we get 30 over here, 4, then 5 comes down, then here I have, sorry, here I have 4, then 40. So now when I use this particular operator, it gives me this answer, and when I use, suppose, division sign, it gives me this as an answer. So this sign gives me the quotient and this sign gives me the remainder. Now the magic in this is what, like if you are using a modulus operator while dividing, and if you have 10 as a number, so any number which you divide with 10, what happens is in the remainder you get the last digit, that's for sure. So this is like one small formula which helps you. Now suppose if you divide the same number, now n, if I modulus with, suppose say 100, when I do this, the same division will happen, 3 4 5, and here I'll say 100, 100 3s are 300, and what I get down is 45. So what is happening out over here is if I divide by 100, I get the last two digits, and if I divided by 10, I'll get only the last single digit extracted. So this logic is there. If I divide it by 1000, maybe it will give me the last three digits. So this is the actual logic over here of just removing, or not removing, I should say, digit extracting from the right hand side, from the units place. So this is your units place, this is your tens place, and this is your 100. So maybe you can have thousands, and you can have like 10,000, whatever, it goes on. Now here, based on this, there are many programs. Now the first normal one which I can show is, for example, if I have n, int n is equal to 123. Now 123 is a number which is stored in n. Now what happens is, if I want to remove one digit from behind, or I can say from the right hand side, and print it on the screen. So how I'll do is, I'll write over here n modulus 10. Now this is why, so that I can extract the last digit, and I can store it also somewhere if I want. So I can store it, I'll take a variable int r. So in r, what I'll get is 3. Now I need to print it on the screen, so I'll say system system dot out dot println, and I'll say r. So this will print on the output screen. Suppose this is my output screen, it will print 3 over there, and the cursor goes below. Now what I want to do is, again if I repeat the same line, it will again remove 3, or it will extract 3. So there again there is a problem. So it's better, okay, I need to update this number. Update the number means I need to reduce the number. Now how shall I reduce? If you see on the top here what I have explained, okay, if I divide any number by 10, by using a modulus operator, I'll get the remainder, and if I do it by division sign, I will get my quotient after excluding the last digit. So the last digit which was there, it was now removed out, and I get the rest of the part. So the same thing I'll do it over here also. So I'll update my number, n is equal to n divided by 10. Now this line which is there, which will actually reduce my number by removing the last digit. So it will become 12. My number becomes 12 over here. I hope this much is clear. Then this same process, rather than copy pasting it again and again, we will use a loop, so that loop will help us out in extracting the digits. Now you will say, sir, till how many times, how many number of times? Now we cannot run a loop for fixed number of times, maybe say one time, two time, three time, not possible. because we don't know no, what number is being entered by the user. Now here I have assigned the value. Maybe if you are taking from the user, like for example you write something like int n is equal to sc, assuming sc is the object of the scanner class, then next next int. If I using this line, that means you're taking from the user. The user might enter any number, maybe it can be 2 digit, 3 digit, 4 digit. So for that we require one formula which will work for any number of digits. So what we are going to do over here is, I'll repeat this. I'll tell the computer while bracket open, I will say, now this number, if you see here, it keeps on reducing. That means as long as I keep repeating this line, the number will become 1, then it will become finally reach to 0. Now beyond this, it will not go. So what we can write over here is n, as long as it is more than 0, you keep repeating this task. So this my one formula will help us out, or for 3 digits also, 4 digits also, 5 digits also, and many more. So this is your actual, what you can say, a code which helps you to extract digits from any given number. So this is what I have to show you all for digit extraction. Now based on this, there can be different programs also, that also we'll see. See, these are all programs which are based on series and your digit extraction. Now one program which is there over here, which I feel I should discuss with you all, is this one. And here it says a duck number. A duck number is a number which contains a 0. Now that 0 should be included inside the number. Like for example, it is 420, so 0 is there over here, so this is a duck number. Or suppose I have 1025, this is also a duck number. But a number which is not having 0 is not a duck number. For example, 1 2 3, it's not a duck number. These two are duck numbers. Now you can ask me, sir, 0 3 5 8, is it a duck number? No, because while calculating, the computer will not consider this 0. So the 0 has to be either at the end, or the 0 has to be somewhere in middle. So that signifies it's a duck number. Now how to do that? Now for this you need to extract digits, remove it from the last, and then check whether, now remove extracting this, like suppose this number is stored in n. So what we can do is n modulus 10. Now whatever outcome is there, maybe the 5 or whatever, so now this digit we can check again. If, now I'll show you the code itself, so you will have got an idea of what is a duck number. Now how to put on in the code, it's very simple. Once you get the idea, okay, this is a duck number, the concept is this, then you can do it. Now see, for I assume k it is being assigned, not taken from the user. So int n is equal to, suppose say 7802, it's a number. Now this number is being assigned in n, so I'm writing over here as my dry run 7802. Now I need to extract digits, so the same logic which we have seen earlier. So I'll be taking a loop while, while, and that I'll say n not equal to, but then see, the problem is, after doing this entire process, my n will turn to 0, but finally I need to show that number right somewhere. So what I'll do is, I'll take a backup of this number. How I'll do that? See, I'll write over here int, suppose I take a backup in some variable, like say for example w, and here I write n. That means now what will happen is, okay, here the original number which is there will remain intact, plus I'll have a duplicate copy, so it will also have the same number. Now after this, rather than taking the original number over here, and for calculation I can take w not equal to 0 or more than 0, doesn't makes any difference. Now here what I'll do, I'll extract a digit, and that I'll store it in a variable, say for example r. So n modulus 10, when I do this, it will remove the last digit from here, and then what to do, then I have to check whether it is 0 or not. So how I'll do that, I will check. For checking, I'll have to say if, obviously I'll use my decision statement. So I'll tell the computer, now you decide what is there in r, whether it is exactly equal with 0. If it is equal to 0 properly, then what to do, we'll have to shout it's a duck number, but then it will again create a problem. Okay, like one digit you extract and then you check it is 0. And if I say over here duck number or not a duck number, so in that case what will happen, every time for every digit it will give me a report. For 2 it will say not a duck, then 0 it will say duck number, then again for 8 it will tell me not a duck. So the answer will keep on repeating. I don't want like this, I want one single answer. So for that one single answer, what we need to do is not to print it inside the loop. We'll have a signal kind of. So what signal I'll do? Now see here. I'll take a variable over here as int d is equal to 0. Now whenever the computer come across this particular line, see this one, this line, if it is true, then what I'll do is I'll change d ka value to 1 like a signal. Now what will happen, whenever it will come across this part like 0, it will change my d ka value to 1, and it will happen once only or maybe twice or maybe thrice. So d ka value, which is 0 initially, it will only turn to 1 once it come across a 0. So now what to do is no tension at all anywhere. So I close this and then I say the line to update my variable. So I'll say n is equal to n divided by 10. Now this will reduce my number, so this will become 7. This will reduce the number to this part. See now 7, 8 and 0, then again it will become 7, 8, then it will become 7 and finally become 0. So this entire thing checks whether the extracted digit which is stored in R is 0 at this point. If it is, then it will change dcas value to 1. And now below what we can do, again we'll check whether d, after the entire process is done, whether d is 1. If d is 1, then I'll say system.out.println, I don't have place over here, I'll write it is a duck number, duck, duck number. Otherwise I can put an else part over here, see else, else, and then I'll put over here system.out.println and I'll say not a duck number. So this way, and then your main class, so main method closing and then the class closing. This is what is there in this program. So it's such a simple program. It can come for 15 marks also, because in the board also it has come, I guess, in some of the paper. So the logic is very simple. I showed you all how to work with a duck number. This is one example of an extraction of a digit. This was one, that is a duck number. Then we have something more also. Now see here down also they have given a solution. You all can go through this solution also. Here they have used a boolean variable, see, where I've used say a number, that is an integer. They have used a boolean variable. Initially it is false. When it come across over here, it will make it as true at this point over here. You all can see this thing. This is what it is, a duck number. They have given a program, I have given mine. So you all can scroll left and right and you all can check, you all can write down this particular code in your book. Now this was duck number. Then we have bus number also. Now bus number is also very simple. If you see bus number ka code is very simple. Here they have mentioned, okay, bus number is a number which is actually it ends either by 7 or it is divisible by 7. So the code is very simple. So first thing is, we take a number from the user. After taking the number from the user, see this point is taking a number from a user, then the same number, like what I said, digit extraction. Like for example, if it is 147, I need to know whether it's a bus number or not. So for that reason I need to first find whether the last digit is my number 7 or not. So for that we have this line, that is n modulus 10. This will give me the last digit, and if it is exactly equal with 7, yes, I can say it is a bus number. Or there is one more way, that is n modulus 7. Now this means what? You are dividing any number by 7, and when the answer comes 0 means it is divisible. This means divisible. So we are checking two things. So it says like either it should have a last digit, or see the middle logical operator says or. That means not compulsory it should be divisible also, and the last digit should be 7. So there is a choice. So here either this one or this one. So when the any one of the condition is true, it goes inside and it prints bus number. So this is also very simple. I hope you people have understood this. Then we have something more. Bus number I showed you. Automorphic number is also very nice thing here. Now automorphic number may, if you will see properly, this type of number, it's we have to check the ending part. Now what is that ending part? See, like for example, a number is taken from the user is 5, that is stored in n, and you need to find its square. So suppose d may will have 25. So 5 5s are 25, that is stored in d. You can have it like this. See, int suppose d is equal to n into n. So when you get a square in d, that is 25. Now what you are supposed to check over here is, now since this is a single digit, you need to check the last digit, last single digit, whether both are matching. If both are matching, means it is an automorphic number. Now suppose we have in n, we have suppose say 25. So the square of 25 would be how much? 625. Now this thing which you can see over here, we need to check out first the number of digits of the original number. Now the original number is 25, so you need to count, okay, how many digits are there. There are 2 digits. So after finding its square, we have to check last 2 digits only, when they are matching with this original number. So if it is matching, then you will say it's an automorphic number. Otherwise we will say it is not an automorphic number. Now here, this particular thing I'll explain you all. See, how to do that. There is a nice way. So there's one small code over here which I've already explained earlier. Now here what am I doing is, I need to find the count of the number of digits which are there. So counting the number of digits is also very simple, and it is given over here. See how I have done it. If you see properly, what I have done is I have taken a number that is n, which is 1 2 3 4, that is 1234. So that is stored in n. Then I have taken a backup over here. Int n1 is equal to n. So whatever number is there in n, that comes in n1 also. So it's like 1 2 3 and 4. Now what happens is, further what I have done, I need to count the number of digits which are there in my number. So see a nice trick which I have used over here. I have taken a variable c, see this one, this fellow who is sitting over here, and then what I'm doing is I'm dealing with only this number which I have taken as a backup. And what I do over here is, I keep incrementing c ka value, and I keep updating n1 ka value. So at this point what is going to happen, the number is going to get reduced. So 1 2 3 like this. Then again it goes up. Now it is 1 2 3, whether it is more than 0, true, it goes inside. My c which was 1, now it will become how much? 2. Then again n is equal to n divided by 10, so again my number gets reduced to 12. Again it goes up. Now again 12 is more than 0, yes, then again c plus plus c becomes 3. So then the next instruction, so this will become 1. Again it goes up. Now here 1 is more than 0, yes, so again c plus plus becomes 4. Then again this line, what happens over here, it's reduced the number, it becomes 0. And finally when it goes up, now 0 is more than 0, no, it's false, so it comes out. When it comes out, see, c is having a number, and that is nothing but the total count of your digits in that number. Now this, why it is important for your this automorphic number, because it checks the last 2 digits whether it is matching. So we need to check out the last 2 digits, last 1 digit, last 3 digits. So this particular code will count the number of digits only in your original number. So now what to do now, see now how to work out with this code. See, first of all I'll take int, suppose say n, and I take a number as 5. We are doing over here automorphic. So now here I'll have to find the square. So I'll write over here int, say suppose d is equal to n into n semicolon. So I have my n as 5, I have my d as 25. Now what I'll do, I need to find how many digits are there over here. Maybe if I take 25, that will be more good example. So the square becomes 625. Now I need to check the last two digits and this number, whether it is same. Now how I'll come to know how many digits are there in the original number? So I'll have to take a backup. So I'll say int n1 is equal to n. So my n1 would be 25. Now what I'll do, see, now I'll have to take one more variable so that I can count and I can keep the count inside it. So int c is equal to 0. So I take c also, that is 0. Then I'll take a loop, for example while, I'll say as long as my backup number is more than 0, what you do is you do c count plus plus, and I'll say n1 is equal to n1 divided by 10. This will reduce my number and it will keep counting c. So c will become, in this case the c will become 1, then it will become 2, finally it reaches to 2. Now what we are supposed to do now, we have c as 2. Now if you see, if you want to extract any digits, like for example 625, if I want to extract the last digit, what I'll do, 625 modulus 10, then I'll get 5. Now if I do 625 modulus 100, it will give me 25. So depends on the number which I divide. So if it is 10, last digit; if it is 100, last two digits; if it is 1000, last three digits. So now how to decide this? We will have an idea. The idea says, okay, we will check. Now what are we going to check now? See, we'll have to divide the original number with something of 10 raised to something. So what I'll do, I'll take my original number, that is n, I'll do modulus, and then I need to divide. Now I don't know what shall I divide with, 10 or 100 or 1000, I don't know. So I'll write math dot power function, bracket open. Now here I'll put 10 comma. Now if I put 10 raised to 0, 10 raised to 1, 10 raised to 3, I can put any number over here. So what I'm going to do over here is I'm going to put c. But if I put c may, there is a count, and the count is what? It is 2, right? So 2 will be the count over here. So when I say 2, so I'll have 10 raised to 2. 10 raised to 2 is how much? 100. So now it will divide over here my original number, that is 625 modulus 100. Now this modulus 100 will extract me this last two digits at this point. Now this should be exactly equal with what? Now what I have done over here, see, I have divided by n. N means what? 625. No, that is wrong. I should have done d over here. Why d? Because I need to check the last two digits of this particular number, that is after finding square. So I should say 625, may say you remove the 25 or whatever the number of count is, and it should match exactly with your original number n. So original number is your 25, that 25 should match with whatever is extracted over here. So if it is 25 again over here, and if both are matching, we'll say it is an automorphic number. Is that simple? So this is your normal code for automorphic number. So I think I have discussed 2-3 examples with you all based on digit extraction. So you people should work on this, practice, and then you will understand how to use this. Okay, so that's it for digit extraction.